This is the CAMP tutorial for the 99999103 Rev A part. We're just going to be making a block stock here, and we're going to continue on the next lesson with making more features in it from a modeling and machining standpoint. So we're going to take our stock blank, and this is a machined blank because the finished part fits within this volume. So we're going to draw, even though this part is called blank, we're going to draw stock around this so that we can accurately put it in a fixture, use collision detection, and set up good setup documentation. So what we're going to do first is we're going to draw our stock. We're going to sketch on the top face. And we're going to draw a rectangle that's just bigger than our part arbitrarily, okay, as long as it's bigger. And then we're going to size that, and our stock volume we're starting off with is 2" by 4". It's 2" by 1" bar stock, but we're going to cut it 4 inches and 100 thousandths long. So there we have our stock volume. Now we want to, in 2 axes, now we want to center this on our stock. Just to draw a line from corner to corner, okay, that gives us center of this rectangle. We're going to right click on the diagonal line we made, make that a hidden line, and then we can do a line on center of our block. When the triangle icon appears, you've got the center of the edge, and we're going to go to the center of the opposite edge. Likewise, we will turn that into a construction line. Now, if we use the midpoint command, we can go from midpoint to midpoint and snap the volume of the stock evenly around the material. Alright, we're going to hit finish sketch. Now we're going to extrude this to make our stock volume. So we'll hit extrude, and we're going to select inside our frame and inside the profile of the part, giving us a blue field. It's going to default to going one way and to creating a new feature. What we want to do is we're going to do two-sided, and we're going to bump in the first direction .0 1. We're going to put 10 thousandths on one side, and then we're going to put the full 1" on the opposite side, which would be 0.99. And we don't want it to cut, we want it to be a new body. So that's going to make it a separate piece. It won't join to the original, and it's not going to cut through the old part. We'll select OK. And now if we open the bodies folder, we should have 2 bodies. The first ones are finished blank, and body number 2 is the raw material we're cutting that out of. So we're going to we're going to left click on body 2, and we're going to call this stock. Okay, press enter. And then we're going to take the body and we're going to call it the part number, which is 1, 2, 3, 4, 5 9s -103, which is the part. Okay, that way we can differentiate between the two. Then we're going to right click on the stock, and we're going to go down to opacity control, and we're going to make it 50% opaque. That way we can see through it. Alright, so this represents the stock we're removing, and there's a little bit 10 thousandths on the top. We're going to set up our stock to go in a vise. So we're going to bring in the vise. You should be able to download this CR Generic Vise 2024 from the assignment, and we're going to roll that 90 degrees according to our setup. You can grab it from the center, kind of move it in position. And we're going to create a couple joints. Now, the advantage of this is it'll show up in our setup information, and you can use it for collision detection. So I don't always do this, but if you're trying to make solid documentation for someone else to set up or yourself, this is a good way to do it. We've brought in the model, we've positioned it, but it's right now fixed in place. So we want to unground it from component so that the vise can be located around our workpiece. We're then going to use a joint between the top corner of the parallel to the bottom corner of our stock. And you got to make sure that this snap point disc is in the same plane as what you're trying to select. And it's going to do a preview animation of where that's going to bring the two parts together to assemble it. Now I don't want to set this up right on the edge. It's better to have it closer to center on the vise. You got a 4-inch piece on a 6-inch vise. The style stops we have for the vices, I don't think we can center this, but let's move it over -1/2 inch, and that's the location of where it'll clamp in the vise. We're going to hit OK, and the entire vise assembly should move to where your part is. Now this back jaw is movable. So what we want to do is, you should be able to see this number here when you start moving, and it's the range it can be. Our stock width here is 2 inches, so if we double click on this and say 2, it'll snap the back of the vise to where we need it to be. Again, this is a visual reference. I've machined a lot of stuff without modeling the vise, but it helps for demonstration purposes. Okay, next, say we're done in design mode. We're going to switch over to manufacture mode. Okay, I got a message about importing CAM data. Not sure what that was for. I did not import it. Okay, so we're now in the setup, and we're going to do our setup for our stock. Now again, this should be a review for most of you. We're going to pick setup. We're going to create a new setup. And we're going to select what is our model and what is our part. Now right now, we've got the model of the vise embedded with our model. So we want to make sure we get the right body that's actually the model. So we're going to select the model as our part number body. Okay. And then on the next tab, we're going to go to stock, and we're going to select, in this case, from solid, and we're going to pick the body of the stock. So now we've got those two items identified. Our stock, if it's done correctly, should be 4.1 or 4 inches and 100 thousandths by 1 inch by 2 inch. That's the material you're going to get. We're going to go back to setup, and we need to change our orientation. So right now the orientation of the part is with Z pointing horizontally, which is not the orientation of the spindle. The Z-axis is always in the orientation of the spindle. So we're going to go to Z-axis plane, and we're going to pick on the top of our part, which will snap the Z-axis normal to the orientation of the spindles facing the vise. And then X-axis is one of these edges. If it changes and flips, it needs to be pointed to the right-hand side to be in the correct orientation for a vertical mill. If it isn't, select the flip axis. Then our origin is going to be based off a stock box point for the first operation only. So we're clamping on the stock, and our orientation, where origin is going to be the bottom front of our stock. Now, why did I select the bottom? When we're manually setting tools, it's easier to set tools on the top of your stock and go from there. We're using probing now. So you are going to use a 1, 2, 3 block to probe, and then you're going to compensate 1 inch in height to move the origin down to the parallel. And one advantage of this is no matter how tall your stock is, your origin doesn't move. And so if the stock's a little bit thicker, you'll cut a little more material, but you'll never hit your vise. If the part's a little thinner, you might cut air on a pass. We don't care. If you put it at the top, it's going to be constantly floating back and forth. All right, you could select the fixture as the model of the vise. One thing I realized is the soft jaws, even though they're hidden, will be included in that for collision detection. So I got to come up with a better method to build a model so that we can use that function. But you could use that for the fixture selection here and give it clearance. All right, so we should have everything set here. We're going to go to our post-processor tab, except for our post-processor tab, and we're going to name this part number. So we're going to call it 1031. So that is the last 3 digits of the part number, operation 1. Program comment is going to be op1. And we're going to set our world coordinate system as 1. It's semantics on a Haas whether you use 1 or 0, it calls out G54. But in the future, you may need to use more than one offset. We're going to select OK. And we've created our new first setup. There we go. All right, now our first pull path. We're going to take a face mill and we're going to skim off 10 thousandths off the top of this. So we're going to go to face mill and we're going to select, and in this assignment should be a Sierra VF1 aluminum library. I would like you to download the one that's off this assignment, and it may be more current and it may be different than what other instructors are using. So let's select that. Sierra VF1 aluminum library, and we're going to use our face mill, which is a 3-inch face mill. Now if you're using my library, it should auto put the feeds and speeds in for what I went on Kennametal's site and adjusted for. Now the cutter can probably do a lot more than that, but this is what we're going to be using. So it should say 50 inches a minute, 25 inches on plunge, and a spindle speed of 2,170. If we go higher than that, which we can, it'll wear out our inserts faster. Okay, we're going to go to the multi-axis tab. There's nothing to select there unless you're using 4 or 5 axis. We're going to the geometry tab. We're just going to let it select, auto-select the boundary of the stock. Then we're going to go to the heights tab. For the most part, where you can leave these at default. Again, we got our retract height and our feed height. They're going to be based off whatever the highest of what's selected. So we have stock top, model top, fixture top. Same thing with the model height here. Or I'm sorry, the top height. Those are setting the planes at which it's going to move rapid or change the feed rate. Now we want to cut down to our model top. So if we look at the right side, our top height should be the top of the model of our stock, and the bottom should be the top of our finished part. It's only 10 thousandths, it's removing. Okay, so that looks good. And we're going to go to passes. We're using a 3-inch diameter cutter to go across a 2-inch face. You can say what pass direction you want to go. We want to go the lengthwise. You get a little better finish that way. And then we want our pass direction to go 0 degrees to that, so straight on. We're going to do a pass extension. I'd like you to go a little more than 1.5 inches. That's the minimum, because it'll pull the cutter 1.5 inches past our stock. But what if our stock's cut a little bit too long? So we're going to go to a pass extension that's going to be 0.17. I'm sorry, 1.7. Okay. We're not going to do a stock offset, and our step over right now is set at 2 inches and a little bit higher, so we'll see what we get. It should go right down the middle of our part. And we don't need multiple depths for this. We're not going to leave stock to leave. We're going to go to our linking tab, and we're going to leave everything at default. You want to make sure this box keep down is selected. And except for a vertical lead-in radius, we're not going to put in a vertical lead-in radius. And we'll hit OK. Alright, so it should just generate one pass. Goes roughly down the center, goes across the face. Okay, so we have one more toolpath to do, and that's to cut the outside profile of this down to the bottom of the model. When we are going to do this, we're going to set up we're going to want to set up a stop for the second operation. You want to make sure it's low enough that it's not going to hit the part. If you were running multiple parts, you would put a stop even for this first side. You don't want to probe every single part. It's a huge waste of time. So we're going to go 2D contour. Okay, we're going to select from our Sierra VF1 aluminum library. We're going to pick the 1/2 inch end mill. Okay, we're going to leave the default settings, 5,000 RPM, 54 inches a minute, and 27 on plunge. We're going to go multi-axis tab. There's nothing to select there. This command will support 4-axis wrap. So you could put, if you had a rotary table in a 4th axis, you could have it do cylindrical pockets for 4-axis toolpath. We're going to go on to geometries, and we're going to select the bottom of our model. To do that, we're going to have to make the stock invisible, and we're going to pick the bottom of the part model. That's the boundary we want to machine down to, and we don't want to hit the steel jaws. The rest of these tabs we can leave at default. The next tab is our heights tab. We're going to, instead of going from retract to stock top, we're going to go to model top because it's already machined down to the top of the model. And then we need to change our top height likewise. It'll save a little bit of time. It's only going to be about 10 thousandths deeper, but this is fine. And then we're going to go to the selected contours, which is the reason I picked the bottom of the part. Now we don't want to have any flash when you machine off the other side. So just to make sure, with a little bit of cutter variance, we're going to go negative 0.005. Make sure it's only 5 thousandths, so we're going to go a little bit deeper than that edge by 5 thousandths. The passes tab, we're going to leave most of this at default, but we do always want to change this default setting from in computer to where. And in this class, I'm going to be asking you to measure your parts before you pull them out of the machine to make sure they're within print, because if they're oversized, you can use wear compensation on the machine to rerun features and have them come in within print. Okay, we are going to do roughing passes. We are going to do a maximum step over of half the diameter of the cutter. So that's 1/4 inch. And we're going to leave the smoothing deviation alone, and we're going to do 1 step over. We now have to go back up because the step over box appeared when we selected that. Our finished pass is going to be 20 thousandths, not 50 thousandths. Okay, so it's going to do 1 rough cut, 1 finish cut. We're going to do we're going to do multiple depths, and our maximum roughing step down is going to be 0.25. Okay, 1/4 inch. The cutter can probably do more, but we're going to be conservative. This is a class. Okay, we're going to do 1 finishing step down. That means we'll do a step down at the bottom, and that's going to act as a spring pass so that any cutter deflection, it allows it to shave off whatever it will shave off without the cutter under load. Our finishing step down, we're going to make that 10 thousandths. Okay. And then if we're going to scroll down to our options below that, we're going to do a finish cut on only at final depth because our end mill is long enough to do that. We are going to rough the final, and we're going to use even step downs. The order by depth and islands only matters when you have lots of different features, so we're going to deselect that. We don't want to leave stock to leave, we don't need smoothing, and we don't need feed optimization. We go on to the linking tab. We want to make sure we keep the tool down. If you ever see the machine do a double pump when it's doing each pass, it's lifting up. That's because that box isn't checked. Okay. We're going to do a horizontal lead in of 50 thousandths. That's going to come in at a sweep angle of 90 degrees from the actual cut. And we're going to have a linear lead in of 50 thousandths. We could do more than that. Let's actually do a linear lead in distance of 100 thousandths. So we've left 50 thousandths of stock on the outside. That'll give us a little bit more distance for it to lead in case the material is bigger than we anticipate. We're not going to use any vertical lead-ins. Radius. We're not going to need to ramp, okay, but we are going to check where our preferred lead-in position is. So let's select the second box, and we're going to lead in on this front right corner. That way the operator can see it where it's plunging. Okay, so you should be able to see it lead in. We should be able to see it in front where the operator is going to view it. We have our 2 roughing step downs, another roughing step down, and then 2 finishing step downs at the bottom. That one goes in depth, the other one goes on just the sides.